we missed a very important concept in quantum mechanics, the momentum operator. Momentum operator in position basis, which we will study today. Our starting point is the infinitesimal translation generator operator. As we have seen in our previous lecture that the infinitesimal translation operator that translate the state by translate the position of the state by amount delta x, which can be written as 1 minus I p delta x by h cut, where p is the infinitesimal moment is position infinitesimal translation generator operator. Translation generator operator. And as we have seen previously that if we operate this tau delta x on an kth vector alpha, it will give, if we represent this alpha in position basis, we can write this as minus infinity to plus infinity dx prime tau delta x prime alpha, and this is x prime alpha is nothing but the representation of the alpha kth in position basis, which is called generally the wave function. This is wave function is generally a function of x. That means some psi of x prime is actually equal to psi prime alpha. Now, what this infinitesimal translation operator does on the kth x dash, it will generate an infinitesimal translation in x prime alpha tx prime. It will change these kth x prime to x prime plus delta x prime alpha. Now if we change our variable x prime plus delta x to x, we can write it minus infinity to plus infinity dx x minus delta x alpha. Now since this is a function of x, then that means this can be written as psi x minus delta x. Now we can expand this function psi x as minus delta x to del x of psi x, and we ignore the second order term since delta x is delta x limit delta x tends to 0, so that's why we ignore its higher order term. Now if we write it here, we'll get minus infinity to plus infinity dx x. This will be x alpha minus delta x del x of x alpha. That means this can be written as minus infinity to plus infinity dx x alpha minus delta x minus infinity to plus infinity x del x of x alpha. So we know that this is nothing but the unitary, the identity operator. That means this is nothing but alpha minus delta x minus infinity to plus infinity x del x x alpha. And as we know that this tau delta x can be written in terms of momentum. If we write that, that means if we 1 minus p delta x by h cut, there is I operate on alpha, it will give alpha minus I p delta x h cut alpha. That means this equal to this actually equal to this alpha minus delta x minus infinity to plus infinity x del x x alpha. From these two relation, this and this, we can write that I p delta x by h cut equal to delta operate on alpha will give delta x minus infinity to plus infinity tx tx x x del x x alpha. Now this means p operator alpha will give minus I h cut minus infinity to plus infinity dx x del x of x alpha. Now let us use the orthonormality condition of this state vector. So what is the representation of this state in position basis? Let us check that. So x prime p alpha will be minus I h cut minus infinity to plus infinity dx x prime x del x x alpha. From the orthonormality condition of the position basis, we know that this is equal to delta x minus x prime. That means I h cut minus infinity to plus infinity dx delta x minus x prime delta x x alpha. That means it will give I h cut del x prime alpha, to which means the representation of the position operator in the position representation of the momentum operator in the position gates can be written as minus ih cut del x x prime alpha prime. Now let us represent this p in matrix form where the basis is the position gates. That means let us write what is the form of this matrix element. If P will be a continuous matrix, then the matrix element P x prime will be what it will be. From this relation we can know that minus I h cut it will be delta x prime x prime x prime x. Again from orthonormality condition we know that minus I h cut del x prime delta x prime minus x. So this is the representation of the momentum operator operator in the position basis. Now let us check another thing. What will be alpha p beta? Now that means it will, from this relation we can write. Now let us impose another thing here to write here, orthonormality condition of x. So what it will be, minus infinity to plus infinity alpha x dx x p beta. So we have used the completeness relation of the position basis here. Position completeness relation told minus infinity to plus infinity dx x is identity operator. So this can be written as we know this thing from the relation, this relation, from this relation, actually here what it means, x prime p x p alpha means. So from this relation we can write this is equal to minus infinity to plus infinity dx alpha x, and it is del x beta. Now we know that this is nothing but the wave function of the state at position x, and this is similarly the, it will be the imaginary value, since x alpha, if x alpha is psi x, then what will be the value of alpha x? It will be psi star x. So that means this is psi star alpha x del x of psi beta x. That is one thing. It is important thing when we want to calculate to the expectation value of this momentum operator in some state. Here I miss a factor I minus I h cut, which is minus I by h cut. Now let us check what is the form of the eigengates of the momentum operator in position gates, in position basis. That means suppose this is the eigengates of the momentum operator, it will give p to p. Then what is the representation or the wave function of the eigengates of the momentum operator? So this p is eigengates of the momentum operator. So that means p is equal to p. Now let us represent it in represent it in position basis. Now let's do that. X will be p x p x p p. Now as we know from this relation, what it will be? It will be, this will be del x of x p. There will be minus I cut p xp. So from here, since this is only function of x and this is also only function of x, that means we can write it is a function of x, function of x comma p. This is actually in general function of x comma p, f of x comma p, and this is also function of x comma p. So minus I h cut t function of x comma p tx is equal to p function of x comma p. Now let us solve this differential equation. Minus plus t f of x comma p integration is equal to p minus I h cut tx integration plus some constant. That will be ln f of x comma p minus plus I px by h cut plus c. That will be f of xp is equal to some constant a e to the power I px by h cut. Now this is some normalization constant. Normalization constant. So this means x p, the eigenfunction corresponding to the wave function corresponding to the eigenkets of the momentum operator is a plane wave. This is the form of plane wave. Now let us calculate the value of a. To calculate this, let us use the orthonormal property of the momentum eigenkets. That means p prime p will be delta p prime p. Since these eigenkets are the eigenkets of a Hermitian operator of the momentum operator, that means this will definitely orthonormal. That means p prime p is equal to delta p prime. So now here you can use the another property, which is the here I use the completeness property. Completeness property of the position basis. Now what is the value of this? So let us calculate that. This will be nothing but integration normalization constant its square. How it is come? So let us see that just explicitly. Here px means x p prime, its star, its complex conjugate xp tx. As we know, the form of xp is a e to the power I px by h cut. Let us use that. Tx minus infinity to plus infinity dx, what it is e to the power minus complex conjugate of this will be minus I px by h cut, I p prime x by h cut, and what it will be I px by h cut and corresponding a star, and there will be a. So that means a star is nothing but a mod its square minus infinity to plus infinity tx e to the power minus I x by h cut is equal to p prime minus p, which is nothing but mod a square. If you if we normalize the variable x by h cut, we will get h cut minus infinity to plus infinity tx by h cut e to the power minus I x by h cut p into p prime minus p, it is into p prime minus p. This is nothing but the delta function mod h square h cut 2 pi into delta this data function p prime p, this delta p prime. That means delta p prime p, since this is actually equal to this p prime p, p prime p means delta p prime p, that means mod a its square is equal to 1 by 2 pi h cut. That means mod a is 1 by root 2 pi h cut, which means the form of the wave function in of the momentum eigenkate is 1 by root 2 pi h cut e to the power I minus I p x by h cut. Now let us see the what is the, now if we in general we need this when we want to repeatedly use the momentum operator, that means what is the value of x prime p to the power n alpha, this is nothing but the minus I h cut to the power n del x prime n x prime alpha. And what is the value of alpha pn beta, that is minus I h cut to the power n integration dx psi alpha star x del x n psi beta x. These two things we need when we will calculate, we want to solve some problem. Actually it comes from if we repeatedly operate with p and see this and do this step, we will see this form will automatically come. So that is it. Thank you.